The history of staplers is a long and largely uneventful progression of minor innovations in paper fastening technology. This story begins in the 18th century, during a time when the need to bind papers together was not yet a widespread concern. Early methods of fastening paper were simple and mostly manual, involving ribbons, pins, and wax seals. These methods were not particularly efficient, but were considered sufficient for the relatively low volume of paperwork that existed during that period. The earliest recorded stapling device is often attributed to the court of King Louis XV of France. This device was designed primarily for decorative purposes, creating a small but functional way to attach papers using ornate staples that were sometimes inscribed with royal insignia. However, this was not a tool available to the public, but rather a novelty of the aristocracy. As time progressed into the 19th century, the Industrial Revolution slowly began to change the way people interacted with paper. Increased literacy rates, greater production of written materials, and the rise of bureaucratic systems created a growing need for reliable methods of fastening paper. Pins and string were still widely used during this time, but they were prone to falling out or damaging the documents. This led to the development of paper fasteners that were slightly more sophisticated, though still relatively simple by modern standards. Early paper fastening devices in the 19th century included various forms of brass paper fasteners, sometimes called split pins, which consisted of two prongs that were inserted through punched holes in paper and then bent outward to secure the stack. While effective for certain tasks, these fasteners required punching holes in the paper and were not particularly convenient for tasks that required frequent assembly and disassembly of documents. This inefficiency gradually encouraged further innovation. It was in the latter part of the 19th century that stapling devices, as we recognize them today, began to emerge. The first staplers were large, cumbersome, and typically operated with individual staples that had to be loaded one at a time. Each staple was crafted from a single piece of metal and was often expensive to produce. These early staplers were primarily used in government offices, banks, and printing establishments where the volume of paperwork justified the cost and effort. The evolution of staplers continued steadily into the early 20th century, with incremental improvements in design and functionality. The introduction of staplers that could hold multiple staples at once marked a significant advancement. This allowed users to complete several stapling tasks without needing to reload the device each time, improving efficiency in office environments. Around the same time, companies began manufacturing standardized strips of staples, making it easier to produce, sell, and use staplers at scale. Staplers from this era were often constructed from heavy materials such as cast iron or steel. They were designed to be durable and long-lasting, though their weight made them somewhat cumbersome to move. Many models were operated by pressing a lever, which forced a staple through the paper and folded its legs inward or outward, depending on the anvil design beneath the paper stack. These devices were largely mechanical, with no reliance on electricity or complex components contributing to their reliability. Throughout the mid-20th century, stapler design gradually became more refined. Manufacturers began experimenting with lighter materials such as aluminum and plastic, making staplers more portable and accessible for use in homes, schools, and smaller offices. A focus on ergonomic design began to emerge, though it was subtle. The functionality of staplers remained essentially unchanged, but the tools became easier to operate and less fatiguing for users. The variety of staplers also expanded during this time. Desktop staplers became a common sight in workplaces, designed for standard paper fastening tasks. Simultaneously, heavy-duty staplers were developed to handle larger stacks of paper, often used in publishing, legal offices, and educational institutions. Smaller, pocket-sized staplers were also introduced, providing a convenient option for students and mobile workers who needed to fasten documents while away from a desk. In addition to handheld and desktop models, stapleless staplers briefly gained attention. These devices functioned by cutting and folding the paper itself in a manner that held the sheets together without the use of metal staples. Although environmentally friendly and safe, stapleless staplers generally lacked the durability and strength required for securing larger stacks of paper, limiting their widespread adoption. As the 20th century drew to a close, electric staplers entered the market. These devices were particularly useful in high-volume office settings where repetitive stapling was required. Electric staplers operated using a small motor or solenoid mechanism that drove the staple through the paper with minimal physical effort from the user. Despite offering convenience, electric staplers were generally larger and more expensive than their manual counterparts, which continued to dominate most personal and small business uses. Moving into the 21st century, the fundamental design of staplers has remained remarkably consistent. While materials have continued to improve, with manufacturers opting for combinations of plastic and lightweight metals, the mechanism by which the staple is driven through paper and its legs are folded remains largely unchanged. Innovations in this era have focused primarily on aesthetic design, minor ergonomic improvements, and the development of eco-friendly manufacturing processes. Some manufacturers have explored the use of recycled materials in the production of staplers, responding to consumer demand for sustainable products. Additionally, compact and foldable stapler designs have been introduced to cater to the needs of mobile workers and those with limited desk space. Magnetic and adhesive features have also been added to certain models, allowing staplers to be mounted on walls, whiteboards, or filing cabinets for convenient access. Despite the proliferation of digital documents and paperless workflows, the stapler remains a ubiquitous presence in offices, schools, and homes around the world. Its simplicity and reliability ensure that it continues to serve a useful purpose in organizing physical documents. The continued demand for paper-based materials in legal, medical, educational, and bureaucratic settings reinforces the stapler's role as an indispensable tool. Over time, the design of the stapler has been adapted to meet regional preferences and workplace requirements. In some parts of the world, staplers are designed to accommodate different paper sizes and staple standards, reflecting variations in office practices. For example, certain staplers are tailored to handle larger international paper sizes, while others are optimized for the letter size formats common in the United States. The color and form factor of staplers have also evolved to align with changing office aesthetics. Where earlier staplers were uniformly industrial in appearance, modern staplers are available in a wide array of colors, materials, and styles. Transparent housings, soft touch grips, and sleek, minimalist designs are now common, although these changes do not alter the fundamental function of the device. In terms of mechanics, staplers generally operate using one of two primary methods. The most common is the top-loading design, wherein the user lifts the top of the stapler to insert a strip of staples into a magazine. A spring mechanism pushes the strip forward, positioning the next staple for use. The alternative is a rear-loading mechanism, more common in certain heavy-duty staplers, where staples are inserted from the back of the device. The anvil, the metal plate located beneath the stapling area, often features two settings. One is the standard setting, which bends the staple legs inward toward each other, creating a tight and secure bind. The other is the temporary pinning setting, which bends the legs outward, allowing for easier removal of the staple without damaging the paper. This dual-function anvil has been a standard feature on many staplers for decades. The refinement of staple manufacturing itself has paralleled the development of staplers. Early staples were made from relatively thick wire, limiting the number of sheets that could be fastened. Modern staples are made from thinner but stronger metals, often coated to resist rust and improve smoothness during insertion. Standardization of staple sizes has further simplified the use of staplers across different regions and industries. Heavy-duty staplers continue to serve specialized roles in environments where large document bundles are common. These staplers often feature adjustable paper guides and depth controls, allowing precise placement of staples. They are capable of fastening stacks that exceed the capacity of ordinary desktop staplers, using specially designed heavy-gauge staples. In niche industries, saddle staplers are employed for booklet making, folding papers along a center line and stapling them at the fold. This is commonly used in small-scale publishing, community newsletters, and educational materials. Similarly, carton staplers and plier staplers are designed for industrial and packaging purposes, indicating that stapler design has diversified to meet the needs of many sectors beyond traditional office use. The humble mini stapler, often seen in student pencil cases, serves the same basic purpose, but in a compact form. These devices are typically limited in capacity, but are valued for their portability. The mechanisms are simplified, yet the function remains identical to larger models. This consistency underscores the straightforward nature of stapler design, which has changed very little over the centuries. In certain offices, long-reach staplers are employed to allow stapling at positions far from the edge of the paper, useful for making booklets or unusual binding tasks. These staplers feature an elongated arm, adjustable guides, and the same lever-based mechanism as their smaller counterparts. Though infrequently used, they are an important part of the full spectrum of stapler types. Another variant is the tack stapler or tacker, designed to staple directly into walls, bulletin boards, or other vertical surfaces. These are often used in construction, upholstery, and display assembly. While functionally different in purpose, the mechanical principle remains closely related to that of the desk stapler. Stapler maintenance is minimal, but not without importance. Users are advised to periodically clear jammed staples, keep the internal spring mechanisms clean, and ensure that the anvil plate remains properly aligned. Lubrication is rarely needed, but may be applied in cases of significant wear. Looking back, the stapler has quietly mirrored broader trends in industrial design, manufacturing efficiency, and consumer preferences. From ornate tools of royalty to mass-produced utilitarian office devices, the stapler represents a convergence of practicality and design minimalism. Its persistence in a digital world is a testament to the continued relevance of physical paper in various facets of professional and personal life. Despite the emergence of adhesive binding, paper clips, and digital document management systems, the stapler endures. Its singular ability to produce a durable and tamper-evident bind in a single motion ensures its ongoing use wherever physical paperwork persists. The evolution of the stapler is a reflection of humanity's steady pursuit of convenience in even the smallest details of daily work. As office environments continue to evolve, the stapler remains an artifact of both past and present. Whether sitting quietly on a cluttered desk, tucked inside a drawer, or mounted on a communal supply wall, the stapler is an unassuming yet essential tool. Its future may hold further minor refinements in efficiency, aesthetics, and environmental impact, but its core function will likely remain unchanged for many years to come. The continued exploration of the history of staplers leads us further into the subtle intricacies of their design evolution, manufacturing processes, and the wider cultural impact of this humble office implement. While the stapler is often overlooked in discussions of technological progress, its sustained presence in workplaces across the globe speaks to its quiet importance in the daily lives of millions. The 20th century, particularly the post-war era, witnessed a significant increase in the demand for office supplies as bureaucratic institutions expanded and the concept of white-collar work became deeply ingrained in the global economy. This growing demand led to increased competition among stapler manufacturers, each seeking to refine their designs to improve functionality, reduce production costs, and appeal to an increasingly design-conscious consumer base. Companies such as Swingline, Bostitch, and Rexel became household names in the world of staplers during this time. These manufacturers invested heavily in research and development, not for groundbreaking technological shifts, but rather for steady, incremental improvements in ergonomics, reliability, and cost-effectiveness. The quest for the perfect stapler involved careful adjustments to lever mechanics, staple feed reliability, spring tension, and the durability of moving parts. An important consideration for stapler design that emerged during this period was user fatigue. Office workers who frequently stapled large quantities of documents were prone to repetitive strain injuries. This prompted engineers to explore lever ratios that reduced the physical force needed to drive a staple through paper. The resulting low-force staplers became a popular subcategory, featuring internal mechanisms that multiplied the user's input force with minimal effort. These staplers became particularly common in settings such as law offices, academic institutions, and governmental agencies, where document assembly was a routine task. The choice of materials evolved in response to changing manufacturing capabilities and economic considerations. Early staplers were predominantly metal, with components fabricated from cast iron or steel. As plastic molding technologies matured, manufacturers began integrating high-strength plastics into stapler bodies, significantly reducing weight without sacrificing durability. However, plastic components also introduced new design challenges, particularly regarding the long-term resilience of moving parts under repeated stress. Stapler aesthetics became an increasingly important selling point during the latter half of the 20th century. The rise of corporate branding and the emergence of office supply retailers encouraged manufacturers to offer staplers in a variety of colors and finishes. This was not merely a superficial consideration, but a response to the broader shift in office culture that sought to humanize the workspace and reflect the personalities of individual workers. Staplers were now available in shades of blue, red, black, and even transparent varieties that revealed their inner workings. The late 20th century also saw the proliferation of novelty staplers, which merged form with function in whimsical or themed designs. These staplers often took the shape of animals, vehicles, or iconic objects. While their primary appeal was decorative, they nonetheless maintained full functionality. Such products were particularly popular among students and in creative work environments where standard office supplies might be perceived as too sterile or uninspired. From a manufacturing perspective, the process of producing staplers involves several distinct stages. Metal components are typically stamped from sheets of steel or aluminum using industrial presses. These components are then bent, shaped, and treated to prevent corrosion. Plastic parts are formed using injection molding, where molten plastic is forced into precision-engineered molds. Once cooled, these parts are trimmed and inspected for defects. Assembly involves the integration of metal and plastic components with spring mechanisms, anvil plates, and staple magazines. Quality control is critical at this stage to ensure that each stapler functions correctly. A malfunctioning stapler not only frustrates the user, but can also lead to paper damage, wasted staples, and in some cases minor personal injury due to staple jams or misfires. This has led manufacturers to develop rigorous testing procedures, including automated machines that simulate thousands of stapling cycles to assess durability. The global distribution of staplers reflects broader trends in manufacturing and trade. While early staplers were predominantly produced in Europe and North America, the latter part of the 20th century saw a significant shift toward manufacturing in East Asia. Countries such as China, Taiwan, and South Korea became major producers of staplers and staples, leveraging lower production costs to supply markets around the world. This shift had economic implications for traditional manufacturers in the West, some of whom responded by focusing on premium models, specialty staplers, or niche markets where craftsmanship and design were prioritized over price. In examining the various types of staplers that have emerged over time, it becomes clear that specialization has been a key driver of innovation. For instance, saddle staplers are designed specifically for binding booklets by stapling along the center fold. These devices feature an open, curved saddle base that accommodates the folded sheets, allowing the staples to be positioned precisely at the spine. While primarily used in printing and educational settings, saddle staplers exemplify how even a simple tool like the stapler can evolve to meet very specific needs. Carton staplers represent another specialized variant. Used in packaging and shipping industries, these staplers drive heavy-duty staples through cardboard and other thick materials. Unlike office staplers, carton staplers often utilize a hammering motion rather than a squeezing motion, providing the force necessary to penetrate dense substrates. They may be powered manually, pneumatically, or electrically, reflecting the scale and demands of industrial packaging environments. Plier staplers occupy an intermediate niche designed for tasks where a standard desktop stapler is impractical. These staplers are often used in retail settings for stapling bags, tags, and receipts, as well as in floristry and certain manufacturing processes. Featuring a jaw-like design, plier staplers offer greater reach and flexibility for awkwardly shaped materials or items that cannot be laid flat. The staple itself, though seemingly trivial, has undergone its own subtle evolution. Modern staples are typically made from galvanized steel, which provides resistance to rust and corrosion. Some staples are coated with adhesives that melt under the pressure and friction of stapling, helping to secure the staple more firmly in place. This is particularly useful in industrial applications where vibration or movement might otherwise cause staples to loosen over time. Staples are manufactured in strips held together by adhesive or thin wire. The length of the strip determines how many staples a stapler can hold at once, directly affecting user convenience. Standard strips typically contain between 100 and 200 staples, although heavy-duty staplers may use shorter strips to accommodate the larger size of the staples themselves. In addition to the common closed-loop staple that bends its legs inward to form a tight bind, there are also open-loop staples used in applications where a more temporary hold is desired. These staples have legs that flare outward, making them easier to remove without damaging the underlying material. Environmental considerations have become an increasingly prominent aspect of stapler production in recent decades. Manufacturers have explored ways to reduce the environmental footprint of both staplers and staples. This includes the use of recycled metals and plastics, reductions in packaging waste, and the development of staple-free staplers. These devices, which rely on cutting and folding the paper itself, have found modest success in markets where environmental concerns are a priority. While staple-free staplers offer clear benefits in terms of waste reduction, their limitations are significant. Most models can only bind a small number of sheets, typically 5 to 10, and the resulting bind is less durable than a traditional metal staple. Nonetheless, they remain popular in certain educational settings, particularly with young children, as they eliminate the risk of accidental stapling injuries. Electric staplers, which first appeared in significant numbers in the mid-20th century, continue to evolve. Modern electric staplers often incorporate optical sensors that detect when paper is inserted, automatically triggering the stapling mechanism. This allows for hands-free operation and is particularly useful in high-volume mailrooms, copy centers, and administrative offices. Battery-powered staplers have emerged as a convenient alternative to plug-in electric models. These devices offer the mobility of a manual stapler with the reduced effort of an electric stapler, making them useful in situations where access to electrical outlets is limited. Advances in battery technology, particularly the widespread adoption of rechargeable lithium-ion cells, have extended the practical lifespan and reliability of these tools. An interesting subset of staplers is the archival stapler, designed specifically for use in archival and preservation contexts. These staplers use stainless steel or brass staples that do not corrode over time, preventing damage to historical documents. In addition, Some archival staplers are designed to exert less pressure during stapling to minimize stress on fragile papers. The ergonomics of stapler design has become an area of considerable research and development. Studies have examined the optimal angle of the handle, the force distribution across the user's hand, and the tactile feedback required to ensure that a staple has been properly driven. As a result, many modern staplers feature contoured grips, rubberized surfaces, and reduced force mechanisms that collectively enhance user comfort. Long-reach staplers represent yet another adaptation in stapler design. Capable of stapling at distances of up to 12 inches from the paper's edge, these tools are frequently used for binding booklets, newsletters, and specialized forms. The extended throat depth is adjustable, allowing for precise placement of staples, a feature critical for ensuring the professional appearance of finished documents. The psychology of office supplies, including staplers, has been the subject of occasional academic inquiry. Researchers have explored the extent to which the physical environment, including the availability and aesthetic appeal of tools like staplers, influences employee productivity and satisfaction. While the impact is subtle, studies suggest that well-designed, reliable office tools contribute positively to workplace morale. Staplers have also occupied a curious position in popular culture. Their portrayal in films, television, and literature often symbolizes the mundanity of office life. The most famous example is the red swingline stapler featured prominently in the film Office Space, which became an unexpected cultural icon. Following the film's release, Swingline, which had previously discontinued that particular red model, resumed production in response to popular demand. Beyond the office, staplers have found unexpected applications in the arts and sciences. Artists have used staples as a medium for sculpture and collage, appreciating the linear, metallic aesthetic they provide. In scientific research, industrial-grade staplers are occasionally employed in fieldwork settings to assemble temporary structures, secure equipment, or bind field notes in harsh environments where conventional binding methods might fail. In emergency medical situations, surgical staplers distinct from office staplers, but conceptually related, are used to close wounds and surgical incisions. These medical devices utilize specialized staples made of stainless steel or absorbable polymers. The development of surgical staplers in the mid-20th century reflects the broader adaptability of the stapling concept to contexts far removed from the office desk. Returning to the office context, the role of staplers within the broader ecosystem of document management continues to evolve. While the push toward paperless offices has reduced overall paper consumption, staplers remain indispensable for the physical organization of materials that must exist in tangible form. Legal contracts, medical records, educational handouts, and governmental documentation all continue to require physical binding. The future of stapler design is likely to focus on further enhancements in sustainability, portability, and user experience. Some manufacturers are exploring biodegradable staples, while others are experimenting with modular staplers that can be easily disassembled for repair or recycling. Digital integration, while unlikely to affect the core function of staplers, may play a role in inventory management for large organizations, with smart staplers tracking staple usage and automatically ordering refills when supplies run low. In conclusion, the stapler's history is one of quiet persistence and incremental improvement. It is a tool that has adapted to changing technologies, workplace cultures, and environmental concerns without ever straying far from its fundamental purpose. Whether found on the polished desk of a corporate executive, the cluttered workspace of a student, or the bustling back room of a retail store, the stapler continues to serve as a reliable companion in the ongoing effort to bring order to the inevitable chaos of paper. As we continue this unhurried exploration into the history of staplers, we inevitably arrive at the subtle complexities that underscore not only their functional purpose, but also their role as reflections of broader technological, economic, and cultural shifts. The stapler's journey is a narrative that mirrors the development of modern administrative infrastructure, workplace habits, and the ever-present human inclination to impose order upon disorder. The rise of the modern office in the 20th century was a consequence of industrialization, urbanization, and the maturation of corporate structures. As companies grew in size and complexity, so too did the need for reliable methods of organizing and securing vast quantities of paper documentation. Staplers became a mainstay of this environment, quietly facilitating the smooth flow of information within businesses, government agencies, and educational institutions. Staplers, while seemingly simple, encapsulate a blend of mechanical precision and human-centered design. The fundamental mechanics of staplers rely upon levers, springs, and pressure plates working in harmonious concert. A subtle but critical part of a stapler's design lies in the interaction between the driver blade and the anvil. The driver blade is the component that forces the staple downward, while the anvil is the base plate with grooves designed to bend the staple legs into their final shape. The precise calibration of these components determines whether the staple clinches inward tightly, remains loose, or jams entirely. Throughout the 20th century, engineers and designers incrementally refined the shape of the anvil to improve staple closure consistency. Early designs featured fixed anvils with a single curvature suited to standard paper thicknesses. However, later innovations introduced adjustable anvils, allowing users to toggle between inward clinching for permanent fastening and outward clinching for temporary binds that were easier to remove. In parallel, the introduction of spring-loaded staple magazines improved the ease of use. Instead of manually feeding staples into place as earlier models required, users could now load strips of staples that were automatically advanced into the firing position by spring tension. This innovation not only saved time, but also greatly reduced the occurrence of jams caused by misaligned staples. Staplers were also subject to the demands of varying paper capacities. A standard desk stapler might accommodate a modest stack of up to 20 sheets, but as workplaces diversified, heavy-duty staplers capable of binding hundreds of sheets became a necessity. These robust models employed reinforced lever mechanisms, larger staple sizes, and often required two-handed operation to apply the necessary force. At the same time, miniature staplers gained popularity for personal use and portability. These compact models, often small enough to fit in a pocket or pencil case, were designed for convenience rather than heavy-duty performance. Despite their size, they often retained surprising mechanical efficiency, capable of binding several sheets together with minimal effort. The interplay between stapler design and cultural aesthetics became more pronounced in the post-war decades. Mid-century modern design principles, emphasizing simplicity, functionality, and elegance, influenced the appearance of office supplies. Staplers were no exception. Smooth contours, minimal ornamentation, and muted color palettes became the norm, reflecting the broader desire for efficiency and clarity in the workspace. During the 1980s and 1990s, the expansion of consumer choice led manufacturers to experiment with bold colors, transparent casings, and whimsical designs. Staplers were produced in neon hues, translucent plastics, and themed shapes that ranged from the mundane to the eccentric. While some saw this as a playful departure from the sterility of traditional office equipment, others regarded it as a reflection of consumer-driven personalization within the workplace. Parallel to this aesthetic diversification, manufacturers focused on enhancing the durability and reliability of their products. Advances in metallurgy allowed for the use of lighter, stronger alloys in internal components, reducing wear and tear over time. High-impact plastics provided external casings with increased resistance to cracks, scratches, and deformation. The role of staplers in education warrants special attention. Schools adopted staplers not only as tools for assembling worksheets and projects, but also as teaching aids that introduced students to basic mechanical principles. The act of pressing a lever, feeling the resistance, and observing the transformation of a straight piece of wire into a secure fastening imparted a tactile understanding of cause and effect. In educational settings, safety became a particular concern. Manufacturers introduced safety staplers with shielded driver blades and mechanisms that prevented activation unless paper was properly inserted. This reduced the risk of accidental stapling injuries, particularly among younger users. Moving into the corporate world, the efficiency of staplers was integral to the organization of paperwork prior to the widespread adoption of digital systems. Files, reports, memos, and correspondence were often compiled manually, and the reliability of a stapler could make the difference between smooth operations and frustrating delays. In law offices, for example, the secure assembly of legal briefs was essential not only for organization, but also for maintaining the professional appearance and integrity of submitted documents. Interestingly, the presence of a high-quality stapler on one's desk became something of a status symbol in certain professional environments. Premium staplers, often constructed from polished metals and featuring precision engineering, were seen as indicative of one's attention to detail and appreciation for reliable tools. Some models even featured engraved logos or initials, further personalizing the object. As globalization accelerated in the late 20th and early 21st centuries, the production of staplers became concentrated in regions with advanced manufacturing capabilities and lower labor costs. This shift was accompanied by an increased focus on standardization, with international specifications emerging for staple sizes, loading mechanisms, and performance metrics. Standards such as ISO 12757 governed aspects of staple manufacturing to ensure compatibility and quality across different brands and models. Environmental concerns gradually entered the conversation surrounding stapler production and use. The manufacture of staples from virgin steel, combined with the widespread use of disposable plastics, led to questions about sustainability. In response, some manufacturers began offering staplers made from recycled materials and staples produced with lower energy processes. Packaging was also streamlined to reduce waste, often employing cardboard inserts instead of plastic. The development of staple-free staplers represented an inventive response to these concerns. These devices, relying on mechanisms that cut and fold paper to bind sheets together, eliminated the need for metal staples altogether. While limited in their capacity, typically effective for no more than 10 sheets, they found favor in environmentally conscious offices and classrooms. Staple-free staplers employed one of several methods. Some punched a small flap into the paper and folded it back into a slit, while others used interlocking cuts that resembled the tabs on cardboard boxes. Despite their limitations, these devices demonstrated the persistent human drive to refine even the most mundane tools in pursuit of efficiency and sustainability. Digital transformation introduced new dynamics into the world of office supplies. As more documents were created, stored, and shared electronically, the overall demand for paper-based binding solutions declined, yet staplers persisted. Their role shifted somewhat from mass document assembly to handling the exceptions legal documents requiring wet signatures, physical contracts, or presentation materials. Electric staplers continued to evolve during this period. Early models were relatively bulky, powered by wall adapters and prone to overheating. Improvements in motor efficiency, sensor technology, and miniaturization led to sleeker, quieter, and more reliable devices. Automatic paper detection became standard, reducing the risk of misfires and enhancing user convenience. Cordless, battery-powered staplers offered further flexibility, especially in mobile work environments. Improvements in rechargeable battery technology extended operating life, while lightweight materials reduced the overall heft of these devices. As a result, mobile professional salespeople, consultants, and field researchers could carry reliable stapling equipment without the need for fixed office setups. One often overlooked aspect of stapler design is its acoustic footprint. The characteristic snap of a stapler closing is an auditory marker of task completion, but can also be a source of irritation in quiet environments. In response, some manufacturers experimented with dampening mechanisms to soften the noise. These so-called quiet staplers found particular favor in libraries, research labs, and shared office spaces where noise reduction was a priority. Within the world of specialized staplers, an intriguing subset includes the wire stitcher. Unlike traditional office staplers that use pre-formed staples, wire stitchers cut wire from a spool, form it into a staple, drive it through the material, and clinch it all in a single motion. These machines are primarily used in commercial printing and bookbinding, offering the advantage of unlimited staple length and reduced supply management. Carton closing staplers represent another specialized domain. In warehouses and shipping facilities, these heavy-duty tools drive broad-crown staples through thick corrugated cardboard to secure boxes for transport. Often powered pneumatically, these staplers must deliver consistent pressure across repetitive tasks, requiring robust engineering and durable materials. Even in agriculture and construction, stapling technology finds application. Fence staplers, for instance, drive U-shaped staples into wooden posts to secure wire fencing. These tools are typically pneumatic or gas-powered, designed to withstand the rigors of outdoor work. Similarly, in roofing, heavy-duty staplers are used to fasten felt, insulation, and even certain types of shingles. The production process of a typical desktop stapler follows a sequence of material preparation, component fabrication, surface treatment, assembly, and quality control. Metal sheets are stamped into shape, often using progressive die processes that perform multiple cutting and forming steps in a single pass. These components are then subjected to treatments such as galvanization, anodizing, or powder coating to enhance durability and corrosion resistance. Plastic components are produced using injection molding, where molten plastic is injected into precisely machined molds. Cooling, trimming, and inspection follow. Springs are fabricated from hardened steel wire wound into specific tension profiles. The assembly process involves aligning the moving parts lever, magazine, driver blade, and base with meticulous precision. Quality control includes functional testing, ensuring that each stapler can cleanly drive staples through a specified number of sheets without jamming. Stress tests simulate prolonged use, with automated machines performing thousands of staple cycles to verify durability. Packaging design serves a dual purpose, protecting the product during shipping and conveying branding and usage information to consumers. Staplers continue to be a point of subtle innovation even in the 21st century. Manufacturers explore antimicrobial coatings for use in healthcare and shared office environments. Modular designs allow for easier repair, reducing waste by enabling users to replace worn components instead of discarding the entire stapler. Smart staplers, although niche, incorporate counters to track staple usage or sensors that notify users when supplies are low. Despite the ubiquity of digital documentation, the tactile act of stapling persists as a satisfying ritual in many work routines. The physicality of binding papers together serves as a confirmation of task completion, offering a sense of closure distinct from clicking a save button. This symbolic function of staplers, as much as their practical utility, underpins their enduring relevance. Looking further afield, museums and private collectors have begun to curate staplers as artifacts of industrial design. Vintage models from the late 19th and early 20th centuries, with their ornate castings and brass fittings, are displayed alongside other tools of clerical work. These exhibits serve as quiet reminders of how even the smallest implements shape the rhythms of daily life. Staplers also occasionally surface in philosophical and artistic discourse. Some artists and writers use the stapler as a metaphor for the constraints of bureaucracy, the repetitive nature of modern labor, or the interplay between order and entropy. Others celebrate it as a symbol of ingenuity, simple machine that solves a complex problem with elegance and reliability. Throughout all of this, the core function of the stapler remains unchanged. It binds, whether bridging sheets of paper, securing cardboard flaps, or fastening wire fencing. The stapler exists to create order from loose components. It achieves this not with adhesives, knots, or complex fasteners, but through the simple transformation of a slender piece of metal. As workplaces evolve toward remote and hybrid models, the stapler continues to adapt. portable staplers gained popularity among home office workers. Compact electric models catered to shared spaces with limited surfaces. Meanwhile, digital native startups occasionally produce artisanal or novelty staplers marketed less for their function than for their aesthetic appeal as desk ornaments or conversation pieces. The supply chain that supports staplers extends globally. Steel sourced from one continent is processed into staples on another. Plastic polymers are refined from petroleum products, molded in factories across Asia, and shipped to distribution centers worldwide. The logistics of getting a stapler from raw material to retail shelf involve a web of transactions, transportation, and labor that mirrors the interconnectedness of the modern world. In summary, the story of the stapler is not merely a chronicle of office supply evolution. It is a window into the broader processes of industrialization, globalization, technological innovation, and cultural adaptation. The stapler's continued presence in our lives, despite countless technological shifts, is a testament to the enduring value of simple, reliable tools. Its click, its clinch, and its quietly efficient presence at the edge of our desks remain constant companions in the ever-changing landscape of work. Of course, let us continue this meticulous and tranquil journey through the ongoing history and evolution of staplers, delving further into the subtleties and nuances that have quietly shaped this unassuming tool's role in society. The continued refinement of stapler ergonomics deserves careful consideration. As workplace research in the latter half of the 20th century began to focus more heavily on employee comfort and the reduction of repetitive strain injuries, manufacturers began to pay greater attention to the tactile experience of using a stapler. Designers studied the distribution of force during the act of stapling, leading to the development of models with contoured handles, cushioned grips, and lever mechanisms that required significantly less exertion from the user. These ergonomic adjustments were particularly beneficial in office environments where stapling was a frequent, repetitive task. In addition to comfort, the question of placement and convenience led to the diversification of stapler form factors. Desk staplers remained the standard, typically weighted for stability during one-handed operation. However, wall-mounted staplers appeared in some settings, particularly in mailrooms or packaging departments, where freeing up horizontal workspace was a priority. Similarly, long-arm staplers became indispensable for specialized tasks such as booklet making or center stapling large sheets of paper, offering extended reach while preserving the fundamental mechanics of traditional models. The packaging industry also pushed for innovation in stapler technology. The need for securing not just paper but thicker, denser materials prompted the creation of industrial carton staplers and plier staplers. These devices, often pneumatically powered, were designed to deliver greater force with minimal user effort. They were equipped with mechanisms that could drive heavy gauge staples deep into corrugated cardboard, particle board, and even certain plastics, ensuring durable closures suitable for shipping and storage. The standardization of staple sizes continued to evolve throughout the late 20th and early 21st centuries. While early staplers were often proprietary, requiring staples manufactured by the same company, pressure from consumers and large-scale buyers led to the gradual harmonization of staple dimensions. This shift benefited not only end users but also the broader ecosystem of office supply distribution, allowing retailers to streamline inventory and reduce confusion among customers. Despite the increased standardization, specialty staples continued to serve niche needs. Variations included copper staples for archival purposes, which offered resistance to rust and corrosion over long periods, and stainless steel staples for outdoor or high moisture environments. Some manufacturers also introduced color-coded staples intended for visual organization, allowing users to quickly identify different sections of a document or to match the aesthetic of a particular project. The relationship between staplers and corporate branding is another facet worth noting. Office supply manufacturers often partnered with companies to produce custom-branded staplers, bearing logos, slogans, or distinctive color schemes. These promotional staplers served dual purposes as functional office tools and marketing collateral. In some cases, these branded staplers became collectible items, particularly when associated with historic companies, special events, or iconic designs. In certain industries, the stapler transcended its basic role and became a symbol of operational efficiency and reliability. Law firms, for example, valued high-capacity staplers capable of binding thick case files without fail. In publishing, long-arm staplers enabled the rapid assembly of zines, pamphlets, and small press books, fostering the rise of independent media throughout the 20th century. Meanwhile, in government agencies, the humble stapler quietly contributed to the organized management of vast bureaucratic processes. The cultural significance of staplers has occasionally surfaced in popular media, reinforcing their role as both a ubiquitous object and a quiet symbol of the mundane. Films, television shows, and literature have portrayed staplers in various lights, sometimes as comedic props, other times as subtle metaphors for the repetitive nature of office life. Such portrayals speak to the deep familiarity that many individuals have with staplers, an object so ingrained in daily experience that it readily lends itself to narrative symbolism